Hello and welcome back to CST 2120. So in this lecture I'm going to talk about callbacks and promises. So I'm going to start with a brief introduction to the problem. Then I'm going to talk about callbacks, how callbacks address that problem, and how we can handle errors with callbacks. Then I'm going to talk about promises and how we can handle errors with promises. Okay, so the problem that callbacks and promises are designed to address is that some program operations take a significant amount of time, right? So maybe our code wants to access a database, maybe we're trying to read some files from the file system, maybe we're trying to fetch some data from the server, yeah? Sometimes these operations can be dead quick if it's a small file or, very quick database operation, but sometimes, particularly if database is busy, then it can take some time to actually operate the data, to interact with the database and get the data that you want, yeah? So what we really don't want to do is that when we're doing those operations, we don't want the website to freeze, right? So if in Java, you may have written some Java front-end code, like GUI code, in FX, something similar. And so if the main thread of the application then goes off and does something like a database operation, then you can actually have the graphics kind of freeze in a Java application. Or, if JavaScript was badly designed, right, then you can have the same thing with JavaScript, that I click on, a search on a web page, and then the JavaScript would go off and get the data from the server, but then the web page would kind of freeze and be unresponsive while that was taking place. Yeah, we don't want these kind of things to happen, right? We want the website to continue to function normally, maybe without the data, maybe the loading page, whatever it is. We want it to function normally, and then behind the scenes, we want this longer operation to be taking place. Now, I've written a lot of C++ code with threads, when I was doing my neural network simulator. And, in that code, I often use threads to kind of go off and do the kind of heavy operation behind the scenes, right? There's a lot of database access. So you kind of, you'd launch a separate thread behind the scenes. This sort of thread would sort of go off and do its thing. And then the front end would remain unfrozen, so you could do other things with the graphics or, display a nice loading page, yeah? Same thing with Java, right? In my third year module, we teach kind of multi-threaded with threading with Java. And then in that case, each separate thread is used to scrape data from a separate website. So again, if one website kind of hangs, doesn't respond to us, we can still scrape data from the other four because the other threads are kind of working as they're kind of separate operations, yeah? So this is a kind of classic solution to this problem of what's called asynchronous operations. Now threads are supported in JavaScript, yeah, and I've never had to use them because we have this kind of much better, nicer model, this kind of asynchronous kind of JavaScript runtime engine, yeah. But if I was writing some kind of heavy stuff like machine learning or something, or processing enormous amounts of data, then maybe it would make sense to use threads in JavaScript. But for more ordinary stuff like accessing databases, talking to the server and so on, we tend to use callbacks or promises to handle these operations that take a certain amount of time, and we want that not to interrupt the main sort of flow of the application or minimize the impact on the main flow of the application. So I'm going to talk through callbacks first. This is an older method for handling what are called blocking operations that enables the operation to be completed. And then what happens is there's a callback that lets the main application know when the operation is finished. Yeah. So the general way this works is we have a function that we create called the callback function. We pass that callback function as an argument to the function that does the main operation, does this heavy operation. That operation takes place. When the operation is finished, the callback function we passed in gets executed. Yeah. And so remember that in JavaScript, that functions can be passed in as just another type of variable in JavaScript, yeah? So we can pass them as arguments to other functions, yeah? I covered that in some of the material last term. So let's go, that's a bit abstract, right? So let's try and actually go through a sort of more concrete kind of actual example, yeah? So what I've got here is a function I've called longJob, because what it does is, basically like loads and loads of adding of small numbers to another number, yeah? So it takes a long time, and you can fine tune the amount of time it takes by adding zeros to the i's and j's, yeah? So I have this longJob, okay? It has a long task. It takes, if it's only a demo task, right? It takes like maybe a second to actually complete, yeah? So when we're executing this longJob, either we can just leave it in the main thread of the application, in which case it might freeze, yeah? The application might be taken up with this longJob and not be able to process events or anything like that. Or a much better way of doing this is to have a callback. In this case, I'm calling it finished. I pass that callback as an argument to the long job function. And then when the long job function is complete, it will call that callback function with the result of the operation. That's how callbacks work in a sort of simple way. Yeah. Now, the callback function that we pass into long job can be a separate function that we've written somewhere else. In this case, I've created a function called callback function, and then I'm passing this callback function into long job when I call it. Yeah, that's one way to do it. Yeah, and so when callback function is called, it's effectively calling this callback function here. That's one way to do it. A sort of more modern or more natural way to do it is just to create an anonymous function. And here, sort of down the bottom here, we've got this anonymous function with the argument result, and then, you know, the bit of code that actually is executed. And then if we pass this anonymous function in, you'll see this far, far more commonly. I've just put this in as an illustration, really. Most of the time, you'd use an anonymous function, and the code inside the anonymous function, which is passed to the function as the callback function, it all gets a bit difficult to explain, is what will be executed when the function's complete. Now, that's a sort of very rough introduction to callbacks. You've probably used some of them already with or without realizing it, yeah? And these work fine when you've got a single blocking operation, right? If I just want to read data from a file and then do something with it, load it into the page, for example, then that works perfectly fine, yeah? It also works perfectly fine if I've got two operations whose order doesn't matter, yeah? But callbacks really become problematic if we want to sequence operations in time. So suppose I've got to read two files, and, you know, firstly I want to get maybe some meta information from one file, and then I'm going to get the main data from the other file. Or maybe I've got two database operations, maybe one search on the database, give me one set of data, and I use that set of data to do a second search on the database. Obviously, sometimes you can chain that to put that together into a nice bit of SQL, but sometimes maybe not, yeah? So in those kind of cases, when I have sequences of asynchronous operations, I have to nest my callbacks within callbacks. And you can imagine, you know, that's maybe works, you know, for one level of nesting, but if we've got like three operations or 5 operations got a sequence, we're going to have some really nasty code that's going to be really difficult to maintain and understand, yeah? So I've sort of, to illustrate this, I'm going to use this kind of file read example. So I've got two files here, data1.json and data2.json. And data 1.json is longer than data 2.json. This is to sort of illustrate the point about asynchronous, or, you know, the fact that there's no ordering in time of these operations, yeah? So because data 2.json is a smaller file, it takes less time to read it, and so the reading of data 2 completes before the reading of data 1.json, yeah? So, and this is a much more realistic example before I kind of created my very artificial callback thing, but this is an actual callback that works properly, yeah? So let's just go through this code a little bit, yeah? So I meant to highlight that, but firstly, I'm importing the file system node module, which by default is just a kind of callback module. I'll show you later one based on promises, yeah? And so here's my callback file reading code with the callbacks, yeah? So I've got my fsread file with passing in different arguments, data1.json, data2.json. And then I'm also passing in an anonymous function here, just as I did with the other example. And this anonymous function will be executed by this module when the file operation is complete, and it'll pass in, you know, any error information about reading the file, and it'll also pass the data information about that file to the callback function, yeah? So within the callback function, I can check to see if there's any errors. I'm going to talk about that later. And then more importantly, I can actually access the data here. So I'm logging out the data. So this function will be called with these two arguments. And if there's no errors, then data will have the results of the operation, in this case, the contents of the file. And then so just to be, and what people often get confused about with callbacks is they're asynchronous. They're going to take place in whatever time they happen to take. And then when they're finished, the callback function gets called. Yeah, and that's the magic of them, in the sense that we can get on with other stuff while the operation is taking place, just like we would with threads. But that magic means that our current thread of code will not necessarily work in a sort of intuitive way, we might say. Yeah. So what will actually happen as the code's executed is we'll get the message about to read file. Then we'll get the message file reading started. And then kind of much later, you know, when the callback thing is finished, we'll get these kind of reading complete messages coming out on the console, yeah? So it'll go here, start the file reading, but it won't finish it. Go to here, and then it'll output, whenever the file reading is complete, these two lines of code here, yeah? And let's do a demo. Okay. Right, so where are we at? File read callback. Okay, so this is basically the code, yeah. And so let's just run it, and I'll show you what it does, yeah. So node file read callback. Okay, and it's worked in order in this case. Yeah, there we go. Yeah. So run it 3 times just to make the point I'm trying to make. Yeah. So the first time I ran it, we got data1 JSON reading complete, data2 JSON reading complete. Second time I ran it, I got the same ordering of the files. The third time I ran it, data2 finished first before data1. Yeah. So this is happening without any synchronization between these events. So even in the code, this one comes first before this one, because this is a smaller file. This one can sometimes, depending on the file sizes and what's happening in the operating system, this can happen, but this can finish before this one. Yeah. So in this case, when I ran this code, if you look at the sequence of events, it did file reading started, where it's gone. So I had about to read files first. Then I had file reading started. That was the next piece of code that was called, in this main thread. And then the third piece, what happened next was that file reading complete. It finished reading data2 JSON, and then it finished reading data1 JSON. Yeah. So the ordering, like the order of operations in my program, in this case, is very different from the order of operations that actually takes place, because these 2 file reading operations are operating effectively as separate threads behind the scenes, and then calling the callback to let the main thread know when the operation is complete. Now, suppose we don't like this random ordering of the file reading, and we actually want to finish reading data1 JSON before we read data2 JSON. So in that case, what we have to do is create a nested callback. We have to put the code to read data2 JSON inside the callback for data1 JSON. Yeah. So this is the sort of example here. So this is the first callback for reading data1 JSON, and if I want data2 JSON to happen after data1, then I have to wait until this function is called. This method, this anonymous function is called. When this anonymous function is called, it's going to log out what happened with the first file, and then it's going to do start the reading of the second file, passing another callback into there, and then this callback will be called when the reading of the second file is completed. Yeah, so here I've got one callback. This is the first callback, the outer callback, and then a callback inside that callback. Yeah, and this is the sort of problem with these callback approach, is that it's really starting already to become quite messy. And you can imagine if I have multiple operations I need to do one that I need to do in sequence, this is going to create significant complexity and difficulty to understand. Yeah. So let's just do that. That's my simple one. I've got my nested callback. So this is the code I just showed you, right? So let's do node nested callbacks. And so here, data1, file ready started, it finishes data1, and then it does data2. And I know, and however many times we run this, data2 is always read after data1 because it's inside the callback from data1. Now, next thing I want to cover is how we handle errors, right? Because of things like file operations, database operations, network operations, they go wrong, right, all the time, right? Maybe the database server or management system's not running, maybe the web server's not running, maybe the file doesn't exist. There's always things that can happen in your code, and you'll be able to write better, more scalable code if you handle those errors properly. Yeah, I mean, there's a real tendency in myself as well as most other people just to want to write the code and get it working, yeah, and not bother with error handling. But then when things go wrong, tracing back the errors can be really fiddly, particularly with a large application of tens of thousands of lines of code. So you really, really need to handle your errors as systematically as you can. It's never going to be perfect, but by handling errors, where they might occur, you're going to minimize the impact of those errors and make it easier to debug your code. Yeah. So in callbacks, you remember there were those 2 arguments. We had the error argument in the callback as well as the result argument in the callback. Yeah. So all we have to do to check for errors is to see if that error exists, and if so, we output that error message. Yeah, and that'll really help you when you're building your code. So in this sort of simple example, we're passing error as an argument, and if that error is defined or exists, has some data in it, then we basically just log out the error and quit. Otherwise, we kind of go on ahead and actually do whatever we want to do with the results. Yeah. So it's really easy in callbacks. Just remember that the first argument is the error, and you need to sort of check to see if it's got anything inside it, and then deal with it if necessary. Okay, well, let's demo it. Okay, so yeah, I'll stick to my same usual example, right? Sorry, not that one. File read callback. So here I've got my, not the nested one, just the standard one. And so if I, for example, try and read a file that doesn't exist, let's make data2 give it the incorrect file name, and then I run it. Where have I gone wrong? I'm running the wrong one, yeah. So it was working rather well. Node. File read callback, that's the one, yeah. And then as you can see here, so again, the ordering does this one. So data1 doesn't have an error inside it, right? So let's just look at what's actually gone on here. So I've introduced the error in data2, and because these are separate functions, and the callbacks are separate, so this one will be launched and successfully complete. It'll try to launch one, and it'll catch the error here, and then logging out the error. That's what it's doing here, yeah? So data1 is fine, because it's this whole separate sort of function, and then it tries to read data2, but it then gives us the error message, no fixed file directory, and I've kind of caught that here and logged it out so that I can deal with it if I need to, yeah? Just get rid of that, because I need a working example. Okay. All right, so that's callbacks, yeah? And hopefully it's fairly simple. Once you understand that a function can be passed as an argument, which happens all the time in JavaScript, then we're just passing in a function as an argument, and when that function is called, it has an error argument, it has an error and a result arguments as well, because it's a function, and then we can check for the errors and deal with the result as needed to. Yeah? But the limitation of callbacks, obviously, is that we have to sort of put callbacks within callbacks within callbacks when we start trying to sequence things in time. And this is where promises comes in, which is it does the same thing. It just does it in a way that's easier to write and easier to write nicer code, basically. Yeah. So it's a modern method for handling long blocking operations. If we do it manually, you can use this promise class to wrap the operation. And if you're building your own modules that you're going to release somewhere or other, then you might want to sort of use promises to wrap complicated operations. Most of the time, as I explained, the promises are built into certain modules and functions. So I'll show you a sort of file read with promises. So I'm going to show you how promises work with actually using a promise class, but most of the time you don't need to bother with that. Yeah. And then there's two ways in which, once you have your promise, you can execute it in a couple of ways. You can use a wait. So when we're within a function that has like the async keyword in front of it, and I'll show you all this in code, then we can use a wait within that function to execute a promise. And if we're outside of a function if we're outside of an async function, just an ordinary function or just outside of any functions at all in a global scope, then there's this kind of way of executing promises, which I personally don't like, as you'll see. It kind of feels more like callback hell than a nice way of writing code to me. But it exists, and sometimes it's quite useful to know how to use it. Yeah. And so the key thing about promises is we can sequence their operation in time. That's the big advantage that they have over callbacks. Well, obviously in a way that's nice, right? Which obviously callbacks can do that, but not in such a nice way. Yeah. So this is a slightly artificial example, but I'll talk you through it just to show the sort of idea behind promises. Yeah. So promises are one of the first things to understand about promises is this async keyword, which stands for asynchronous, which means it's happening, at a sort of on a outside the main thread of the operation on a time scale that is determined by what it happens to be doing. Yeah. So we have to put an async keyword before a function means that function returns a promise. Okay. And a promise, the way to think about a promise is it's a promise to do something. Yeah, like I promise to, do the shopping tomorrow or something like that. I'm saying something that I'm not actually doing, but I'm kind of committing to doing. Yeah. So it's a sort of commitment to an operation. And then, someone might say to me, well, David, you committed to doing the shopping tomorrow. It's tomorrow. Get on with it. Do the shopping kind of thing. And it's the same thing with promises. We write the code that promises to do something. And then when we sort of tell the promise then we execute the promise to make that code actually run. Yeah. So async functions return promises, and the good thing about async functions is we can use the await keyword within async functions as well. But in this case, this is just a function that's building a promise and returning it, and that's why I'm calling it an async function. Yeah. And then we have this kind of promise syntax, yeah. So promise, it's like a class in JavaScript, and we pass as an argument to the constructor of a promise a function that has whose arguments are themselves functions, yeah. So it's function within functions within functions. I kind of covered this in my lecture on advanced JavaScript. There's an awful lot of this kind of stuff when we're working with JavaScript code, yeah. So promises are this is the constructor of the promise class. We're passing in a function, and that function has two arguments as its functions called resolve and reject. And it's a bit like a callback in the sense that when the promise is executed, it does whatever it does, accesses the database, in this case the long task that I used in my illustration earlier. And then the promise class will call the resolve function to indicate that the promise has been completed, yeah? And it would call the reject function if there was an error and pass in the error message as appropriate, yeah? And resolve is passing the result of the operation, which will then be returned back to whatever's calling the promise, yeah? So we're building a promise, passing in these two arguments, resolve and reject, and we need to call those when everything's done. And then reject, I'm going to talk about later, but through a more worked example. And then because it's an async function, we can return the promise, and then we can execute it. Yeah. Now this is all very longhand. Just to explain how promises work. So I can then, once I've got a function like that returns a promise, I can then get the promise from that function, use the function to build the promise, and then I can execute the promise. In this case, I'm using the then keyword. So when you click on then, when you use the then function, I guess it is, then again, we're passing in a function, in this case an anonymous function, with the result as the argument, and we can then, so we use then, we pass in the anonymous function with result as the argument, and then we can then output within this anonymous function whatever happened in the promise, yeah? And what happens inside the then function that we pass comes after the promise has been executed. So what it'll do is it'll execute the long task called resolve, and then with a certain number as the result, and then that number will be passed as the argument to this function here, and then we can output it here. If it sounds a bit hairy, it's probably because it is a bit hairy, but once you get to the hang of using them, all these details don't matter so much unless something goes wrong, yeah. And then most of the time, it's really quite easy to use promises, yeah. So this is a pretty heavy example because I'm creating my own promise and I'm returning it and then I'm executing it and all this kind of thing. Most of the time you don't have to worry about that kind of stuff, yeah? Because modern JavaScript libraries come with promises built in. So you don't have to do this unless the only time I've had to do this particular kind of stuff is when I had a library like the MySQL library for Node, which maybe now is promise-based, but didn't used to be promise-based. So I had to wrap it in my own promises so I could sequence database operations, yeah? It wasn't hard, but I had to understand this in order to be able to do it, yeah? But most of the time, you don't have to bother with that because most modern JavaScript libraries are promise-based already, yeah? So let me show you this with the modern kind of file system library, which we just import from fs/promises. And I hope you can see already by looking at this code that it's way, way nicer than that nested callback example I gave you earlier. Yeah, it's basically doing the same thing, but in just much neater, cleaner syntax. Yeah. So here I'm using the await keyword. So this will only work within an async function. Okay, so that's critical. And so here I've got my two operations. I'm going to read data1 JSON, going to read data2 JSON, and I could potentially output the results. I'm not going to bother because just for clarity, really. Yeah. So here's the operation that I'm doing. Previously, I had to pass in a callback function to the read file operation. Here, I'm just calling it. And what this is this will be an async function, which will return a promise. And to execute that promise, I have to call await. And when the promise is executed, it will return. And you will get an error if you try and call await within a function that's not an async function. It'll just say in the JavaScript error can't run this. It needs to be inside an async function. So that's the error. If you get an error, must be inside an async function. And then when the promise is executed through this await thing, then it'll return the data, and then I can do what I like with the data. In this case, I'm just logging out some stuff. Yeah. And then I'm calling that function, and when I call an async function, it doesn't matter. I can just call that anywhere. I don't have to use then or anything like that. I can just call it. So it just means that whenever I want to use await, I have to put it inside an async function, which I can then call from another function. Just in a normal way. Yeah. So again, remember the promise is like me going to do the shopping tomorrow, right? So that's just a promise. And then when someone holds me to account and forces me to go and do the shopping tomorrow, that's like the execution. I actually go out there and do the shopping, and then I bring the shopping home. And that's what's happening here, right? I'm bringing the shopping home, you know, after I've actually executed the shopping. Yeah, same basic idea. Yeah. So let's have a little look. Some of this code is not terribly exciting, but I'm going to do it anyway. Yeah. So file read promise. So this is essentially the code, right? So because we're using promises here, we have a nice fixed sequence of events. Yeah. So it'll say about to read files, then it'll read file 1, read file 2, and say file reading complete. Yeah. So let's just run that. Yeah. So let's just clear that. So node file read promise. As you can see here. So, and however many times I run this, it's always going to give the same sequence of events, because the await will wait until that operation is finished, then it'll return the data for file 1, then it'll do that, return that, and output the results. Yeah. So pretty neat, pretty easy, and I hope you can see by looking at this that this way of writing things is really, really intuitive and logical. Yeah, we've got one thing happening after another, and we know exactly what's going on. Yeah. Okay, so talks about error handling with callbacks, where we have this error as one of the arguments to the callback function. Obviously, we also have to handle errors with promises. So inside async functions, like the one I just showed you, we can use the sort of try, catch, and finally to handle the errors. Yeah. So try is the thing we're trying. Catch will handle the errors. So if an error is thrown, it'll turn up in catch with the error message. And finally is like a block of code that we execute, you know, at the end of the operation, regardless of its success or failure. Yeah. So classic finally would be if we're connecting with the try might try and connect to a database and then execute some SQL statements. The catch would handle errors with that. Say the SQL was incorrect, and then the finally would kind of close the database connection. That'd be sort of, sometimes you don't need the finally, but sometimes it's quite useful. Yeah. And the same kind of idea happens with then, and I'll sort of show you both just to make it clear. Yeah. So in this kind of read file example, remember it's an async function, it won't work. And so this try catch syntax again won't really work properly if you're using then or if it's not an async function. So, you know, await has to be an async function. So what we do is we try and read file 1, okay, and output the results. Now, if for example we got the file name wrong, and I'll show you that, then we'll end up in this catch block because something went wrong in here. So we end up in here with the error message, and then at the end of it, we might want to tidy up. You know, suppose we were writing to a file instead of reading a file. Suppose we were writing to a file here, and you know something went wrong. You know, who knows what. But then we might want to delete the file that just in case it was created, just to not leave junk around. For example, that'd be a good use of finally here. Yeah. Now with then, I personally don't like it. I think it's really messy. It feels like callback hell to me, but you know, it's another legitimate way to do it. So here's the operation, the promise-based operation that we want to do. Remember, it's not like the one I showed you earlier. It's just kind of easy, right? Because fs read files async, so we can then do then afterwards. Then we'll call this callback function after when this is complete. This will be called with the result, and then we can log out the result. If there's an error, we then do this kind of .catch syntax and pass in the error message to a second callback function, second anonymous function, and then again a third anonymous function will be called at the end, which we could use to clean up database operations if we needed to. Yeah. So let's just I'll run through the code just to show you. Yeah, and maybe that'll help. Yeah. So let's have a little look. Promise error handling. That's it. Yeah. So here's my first example. Yeah, I've got file here, data1, so it's all correct. Let's just check it's right. Yeah. So node promise error handling. Okay. So without any errors, it works totally fine. Yeah. Now let's just change the name of the file, similar to the previous example. And so here, right? So it's tried to do this. Yeah. Didn't get to here because of the error, or didn't do any of this stuff because it didn't work. Yeah. And so here we get thrown into the catch block here with the error, whatever happened. And if I'd bother putting an error, oh yeah, and then finally, and then it's also calling the finally at the end of it, and then that's all handled tidily. Yeah. If you don't do this, if you don't catch the errors, they'll be thrown up to the next level, whatever application is calling it. And so in many cases, you want to be able to catch the error so you can display a message to the user. Whereas if it just crashes your entire JavaScript application, then you know that's going to be difficult. Yeah. So that's with the try catch finally syntax. Let's just put that back, and then I've got the same kind of thing with the with the then syntax, which personally is less code, but is really, yes, this is less code than this, but frankly, this is way easier and nicer to understand than this. And once you get multiple things sequenced in time, you can do then and then and then with all the try catches, and it's just stuff of nightmares in my opinion. But some people like the syntax, and and everyone's different, right? So initially we ran it, so we got success, and then finally, so success and finally. And if we introduce an error into here, oops, then you'll see that we get the same. It's throwing the error here. We're not getting the success. It's going straight into the error, and then it's calling the finally at the end of it. Yeah. Okay. So we often have these kind of long operations. They're kind of often outside of the JavaScript runtime environment, depending on databases or servers and so on and so forth. Yeah. And if we sort of waited for them to happen in the main thread of the operation, then everything would freeze. So what we typically use in those situations are either callbacks or promises. Yeah. So callback, we pass in a function to the operation, to the function that's carrying out the operation, and then our callback function is called when the operation is complete. Yeah, that's a nice way to do it. JavaScript handles that beautifully. But the problem with callbacks is that when we want to do one thing and then another thing and another thing, to sequence these things in time, we have to nest callbacks within callbacks within. You have to nest each function within the callback of the previous function. We can end up with these long chains of complicated callbacks, which is not good at all. Yeah, really hard to understand and maintain code like that. Yeah. So promises are introduced to kind of handle this problem of callback hell. And so that lets us use the await syntax, which works within an async function. It means we can then await one operation to complete, and then we can do another and order them nicely in time. There's also this kind of then method of chaining operations in promise operations, but personally I'm not that keen on that. And whether you're doing callbacks or promises, you always need to handle errors. Yeah, stuff goes wrong all the time, and you want to handle the error where it occurs, not just pass it back up to a function, which might pass it back up to another function. If you're not careful, these errors are just occur in multiple different places. I've had that a lot in Java, for example, and then it becomes really difficult to find out which bit of the code actually broke. Yeah, so do your best to handle errors within the place where you know what's happening, and you can provide some kind of useful message to inform what's actually happened. Yeah, and there's appropriate mechanisms for that both within callbacks and within promises. And that's it.